This is Professor Pelton. This is Algebra 2, Chapter 7, Section 4, Adding and Subtracting Rational Expressions. Really adding and subtracting, it's the same exact rules, just like pre-algebra. You still want to find the lowest common denominator for each expression and multiply by that top and bottom a value of 1 to be able to get common denominators, and then you can just simply add from there. So if you're good with your grade school fractions, there's no difference here other than finding denominators that involve algebraic terms. So first we're going to start with monomial review from Algebra 1, then we'll do polynomial for Algebra 2. Okay, so if we look at the fractions here, the denominators are 4x and 2x squared. Those are clearly not like denominators. So 4x in a factor tree is 2, 2, and x. There we go. And 2x squared is 2x and x. Okay, so my lowest common denominator, what do they have in common? They have a 2 in common, and they have an x. Ooh, wow, what happened there? I don't know what that was. Okay, so they have a 2 in common, and they have an x in common. Okay, what's left over is a 2 and an x. So that gives me 4x squared. So that is my lowest common denominator. So I'll rewrite my problem now. 7 over 4x plus 3 over 2x squared. So the 4x is missing another x to get it x squared, right? So multiply it by x over x, which is 1, just like you would in a numeric fraction. And 2x squared needs to be 4x squared, so it's missing another 2. So multiply by 2 over 2. So that gives us 7x over 4x squared plus 6 over 4x squared. Okay, for a final answer of 7x plus 6 over 4x squared. We're not going to talk about domain restrictions with monomials, because obviously it's going to be just where the singular variables are equal to 0. It might also be helpful to go back and watch some like 4th grade videos and adding fractions to kind of compare if you want to. Okay, let's do the example problem B, which is subtraction. That's the only difference. Okay, so here the 9xy cubed breaks into a 3, 3, x, y, y, and y. Okay, came was a weird 3, I'm not sure why that is. And the 12x squared y is 3, 2, 2, x, x, and y. Okay, lowest common denominator. What do they have in common? They have a 3 in common. Numerically, nothing else. They have a singular x in common. They have a y in common. And what's left over? There is a 3 left over. There are 2 y's left over. Oh, I put 3 y's. There's 2 y's. I'm sorry. And we have a 2 2's left over. And an x left over. Okay, so the lowest common denominator is, let's see, 3 times 3 is 9, times 4 is 36, and x squared y to the third. So that's our lowest common denominators. You can also look at them too, and 9 and 12, lowest common denominators is 36. This has 1x, that has 2x's, so they have 2 between them, and then there's 3 and 1. So basically the higher of the variable exponents is the lowest common denominator for the variables, and you can do the numbers the same way you've always done since 4th grade if you want to. Okay. All right. So 2 over 9xy to the third minus 1 over 12x squared y. So to get to 9 into 36, I need to multiply by a 4. But I need x squared y cubed, but I only have an x to the 1, so I need to multiply by another x. So essentially, I just multiplied by 1, which doesn't change the problem. On the other hand, the 12 needs to be a 36. I need to multiply by a 3. I need x squared y cubed, so I already have my x squared, but I only have y1. But I need 2 more y's. Okay. So as a result, we get 8x over 36x squared y cubed minus 3y squared over 36x squared y cubed. So for now, we can actually subtract the numerators, which are not like terms, but that's fine. The point is to get one singular term, which is considered simplified, 36x squared y cubed. Okay. All right, pause the video, try the student problems for yourself on the Monomial Algebra 1 review. Okay, student problems. We have 6x, which comes up to 2, 3, and x. And then we have 4x squared, which is 2. Ooh, you kind of jumped there. X squared, which is 2, 2, x, and x. So lowest common denominator equals, what do they have in common? They have a 2 and an x in common. What's left over? A 3, a 2, and an x. Okay, so let's see, 6 times 2. So we get 12x squared is our lowest common denominator. Okay, so 8 over 6x minus 8 over 4x squared. Okay, so the 6x needs to be multiplied by 2 to get 12, and x to get the x squared. All right, the other term, 4x squared, needs to be multiplied by 3 to get the 12. And that's it, because we already have the x squared. So that gives us 16x over 12x squared for the left term, minus 24 over 12x squared for the right term. So now we can subtract the top, even though they're not like terms. 16x minus 24 over 12x squared. Okay. All right. And again, we're not going to bother specifying domain restrictions since it's monomials, because they're always just going to be 0 for x's and y's. Okay. Second student problem. We have 10, whoops, turn the marker on there. There we go. 10x squared y to the 5th and 15x cubed y squared. All right, so I'm going to write LCD over here, lowest common denominator, and we'll do the strategy that I suggested before. So 10 is 2 and 5, and 15 is 3 and 5. So they have a 5 in common. That's not a good 5. And what's left over is a 2 and a 3. Okay, so that gives us 30, because 10 and 15, the lowest common denominator is 30. So as far as the variables go, you can do the same thing, or just look at the higher value. So I have x squared and x cubed, so it must be x cubed. Then I have y5 and y2, therefore it must be y5. So that is the quicker strategy versus doing it the long, grade school method of lowest common denominators if you want to do it that way too. Okay, so let's rewrite the problem. 4 over 10x squared y to the 5th plus 5 over 15x cubed y squared. So I need 30, so I need to multiply this by 3. I'm missing an x because I need x cubed, so I need one more x. And the y5 is fine because that's what the lowest common number should be. All right, the next one, 15 should be 30, so I need to multiply it by 2. The x cubed is fine, but the y needs 3 more y's to get y to the 5th. Okay, so if I rewrite the problem, I get 12x over 30x cubed y to the 5th plus 10y cubed over 15x cubed y to the 5th. I don't know why those came out weird. Let's fix them. Okay, so that's a third, and that's a 5th. All right, now we can actually add these. They're not like terms, so the numerators just stay as they are. So 12x plus 10y cubed over 30x cubed y to the 5th. Because again, the point is to have a singular term when you're all done, okay? And don't worry about domain restrictions on monomials, because just whatever x and y is 0. Okay, the polynomials are more of a concern. That is the end of part 1.